Morning, everyone. Welcome to our week 5 um, of this Math 13218 Advanced Mathematics class. Today, we will talk about second order constant coefficient linear ODE. So, in the previous session, on multiple occasions, I have explained what is ODE, ordinary differential equation. It doesn't involve any partial differentiation in it. And that's why it's called ordinary differential equation. So far, what we have seen was linear differential equation, linear ODE. So by linear, as similar to linear equations, there is only one power. So we are only talking about y dash or dy by dx, and they are not multiplied. That's the linear. Okay. Now we'll still focus on a linear, but we will go for second order. So first order linear, like I said, dy by dx only. Linear, they are not multiplied together. And there'll be two parts of it, the constant coefficient and the variable coefficient. Today we are focusing on the constant coefficient only. Cool. Before I go into today's content, I'll quickly advise that I have set a session today 3 p.m. and there'll be one more on a Friday. I'll shoot an email to everyone. So you should check your email. I don't like to post tons of announcement because I know everyone is busy. So only the most relevant one, right? Not like our model site is ready, video is released, all that. You can anyway see that. I don't want to keep bombarding with unnecessary emails or announcement. But whatever I shoot will be absolutely relevant, right? So 3 p.m. today, and there'll be one on a Friday. Timing to be advised. The reason for that, it's better to discuss question face-to-face or one-to-one via Zoom rather than back and forth email chain, because then I might type something which doesn't make sense, right? And it's not quick response as well. So I would strongly encourage, if you have some doubt, please come into this session and please spare time to come to the lecture, right? It will be not fair if you're not attending and just keep asking question or not following. I'm still supporting. I'm not saying that I don't entertain, but it's not balanced. It's not kind of fair. Yeah. Anyway, good. So shoot me an email and I will organize as many support sessions as I can. Mostly one every week. That's for sure. Okay. Right. So this is the standard form of second order linear ODE. So d2y by dx2 plus px dy by dx plus qxy is equal to rx. If the right-hand side, the rx term, is 0, then we call it the homogeneous differential equation. So if rx is 0, we call it homogeneous differential equation. Okay. Now, this is similar to our linear equation. What we know about linear equation? Ax squared plus bx plus c. Sorry, what I mean is quadratic order 2. Yeah, so we got x squared. So we got d2y by dx squared. We got x, we got dy by dx, and some constant. Because this is differential equation, it's been structured differently, right? And you might have something d or anything here, and then you make c minus d is equal to 0, right? Okay. Another important point is please keep a copy of the book. That's kind of handy. It has a lot of sentences in between, which will, if you read it, it kind of makes more sense. Yeah. So please keep a copy of the book if you haven't got already. Right. So similar to what we have discussed earlier in the first order, the solution will have two parts, YH and YP. Yeah. So YG, the general solution, will be YH plus YP. YH will be related to the homogeneous one, and yp will be the particular solution related to inhomogeneous, homogeneous and inhomogeneous. Okay. I'm not going to talk about what we have already discussed, but just quickly refreshing our memory. When we are talking first order, we were talking about mu x, right? The solution back then was y is equal to mu x c e raised to q over mu dx, yeah? Where mu is c e raised to minus p dx, yeah? So please remember that. So there was two parts. That's more essential thing, yeah? Yh plus yp. With a constant coefficient, as you know, we are talking about constant coefficient in today's session, but in week 6, we'll be talking about variables as well, right? Okay, but slowly, we are building up, okay? Right, so the general solution YH for the first order homogeneous linear ODE contains one unknown. As you can reflect here, we are only talking about C, okay? Um, But now we are talking about second order, right? So first order is one. Second order should have two constant, you know. Now I will talk a bit about, and that will be represented by edge, will be C1, Y1, C1, C2, Y2, right? C1, Y1 plus C2, Y2, where Y1 and Y2 are linearly independent particular solution of second order homogeneous linear differential equation. Now I'll talk a bit about linear independent. So there is a good definition that I found in one of the book. Give me 1 second, bring up that definition. It's a very good definition because when we are teaching mathematics, we should talk in a language of mathematics, isn't it? Right. And then I'll explain what each of it means. Okay. Right. So there are two terms here. Okay. I'll explain it a bit. So I'll write linear dependent. I'll call it LD, and linear independent, LI. Okay. It's very important to understand them, at least theoretically, and when we are doing the question. Right. So what we mean by linear dependent. So let's say your solution is y1 and y2. Right? Y1 and Y2. You don't want them to be multiple of one another. So let's say you say y is equal to e power x is a solution. You don't want the other solution, y2 is 2e power x. Then you are not bringing the actual c1 y1 plus c2 y2 thing. This y1 and y2 are not simple multiple of one another, right? That's why we are calling it linearly independent. Okay, how it is connected with your other stuff. When you say linear dependent, they are kind of on the same line. So linear dependent is like x and 2x, right? So if a line is x, they are like 2x, or they are collinear points when you're talking about points. But what we want something is like x and another one as like 5x or x plus 3, something totally different. So your whole solution, c1y1 plus c2y2 makes sense. So mathematical definition, if you got two solutions and you write them like this, c1y1 plus c2y2 will only be 0 only if both c1 and c2 are 0. Okay, when you got two variables or solution y1 and y2, if you arrange an equation c1 y1 plus c2 y2 is 0 is only possible if your c1 is 0 and your c2 is 0. If that happens, they are linearly independent. Okay. Example of linear independence is like this: e raised to x and x e raised to x. If you happen to write C1 e raised to x plus C2x e raised to x, the only way you can make them 0 is you take C1 and C2 0. Okay? Linear dependent. If your C1 y1 plus C2 y2 is 0, right, then at least one of them is non-zero. At least one of C1 and C2 are non-zero. For example, x and 2x. So when I write C1x plus C2 2x, if that's a 0, I could have let my C1 as minus 2 and C2 as 1. They are non-zero. And when I replace it here, what will I get? Minus 2x plus 2x is 0. They are called linearly dependent solution. We will never accept something as linearly dependent as two individual solutions, right? Similar to quadratic equation, you have two roots. Here we will have two solutions which are linearly independent. Okay, so that was a bit about linearly independence. Okay, right. I will quickly add a slide. Okay, so to not make it complex, we will choose the solution where y1 over y2, the solution ratio y1 over y2 should not be a constant. So if in this case, you can see it's a constant. Yeah, 2x over x, which is 2, is a constant. The solution is linearly dependent. But in the other instance, x e raised to x over e raised to x is x, which is not a constant. Yeah, and therefore, that is linearly independent solution. Okay, right. Let's look at an example, right? And again, I will explain what will happen if you choose linearly dependent solution. So let's pick up an equation. Y double dash plus ay dash plus y is equal to 0. A can be any constant, right? And let's pick up two solutions. Y1 is equal to 5x. And purposely linearly dependent, y1 is y2 is equal to 10x or negative 10x, doesn't matter, right? Now, if we have to verify whether these are the solution of the given equation or not, what we do, we differentiate and put it up here, right? So what will happen? I mean, you can always verify and go for, but the general solution, as we know, C1y1 plus C2y2, what will happen? C1 times 5x, C2 times minus 10x, right? So can I call it 5C1 minus 10C2x? Now, whenever you got 5C1, 10C2, you can always replace it by constant Cx. Then I got only y is equal to Cx. All right. So when I say y is equal to C, this is what I mean by C. Yeah. But this is only one part of it. For a second order, we should always have C1y1 plus C2y2. When you talk about one constant and only one term, you're talking about first order, not the second order. And that's why it's very easy to observe that y1 over y2, which is 5x over negative 10x, is minus half, which is a constant. Therefore, they are linearly dependent. So such a solution are not good for us. Okay? Such a solution are not good for us. Okay? Make sense? Good. Right. So let's talk about the structure of general solution of second order ODE. So whenever we say general solution, it will talk about the homogeneous solution, solution of homogeneous part, which is C1y1, C2y2. When we say that, By default, we will keep in mind they are linearly independent, not multiple of one another, plus the component yp. Okay, and then we can extend that to more than second order, right? So let's go ahead and verify with one example, right? How that solution is and everything. So the question says verify if y1 and y2 are Li solution of the differential equation this, and then construct your general one, and then find out the yg. What is your yg? It's on a page number 34 of the book. Yeah, page 34 of the book, right? So if we have to verify they are the solution, like I mentioned here, you can always differentiate once and twice and plug it back in. And from there, you can always verify. That's what we are doing here. So I'm given two solutions, right? What I will do, right? I will plug them in, okay? One by one and verify that they are the solution. Okay, so let's start with the first one. Y1 and Y2 are just a symbol, but that's technically Y, okay? But you can't write Y is equal to E raised to X and Y is equal to X E raised to X. Then you got two different values of Y, but they are represented with the Y1 and 2, but they are only, the same thing. They're both Y. Okay, so let's start with the first part. When I say Y1, which is Y is E raised to X, my y dash is e raised to x, and my double dash is e raised to x. Please recall differentiation of e raised to x is e raised to x, right? You can differentiate it once more, it still remain e raised to x, right? Now, I got the value of y dash, and double dash, which I'll replace in the original question or equation if you cite. My equation is y double dash minus 2y dash plus y. I don't write is equal to 0 because I'm verifying it. I'm not yet aware whether that will be 0 or not. Y double dash, which is e raised to x, minus 2e raised to x plus e raised to x. As you can easily observe, e raised to x, e raised to x, so that's 2e raised to x minus 2e raised to x is 0. And therefore, y is equal to e raised to x is a solution. We don't say the solution because there could be more than one solution. Okay, with a quadratic equation, right? We know that these are the solution. Two solution, that's it, no more, nothing else, right? In differential equation, we said this is a solution. Okay, now we verify the second part, the second solution, right? Okay, what we got? Y is equal y2 or y is equal to x e raised to x. Let's talk about this differentiation. We go for the product rule, right? So those watching recording can pause here and try the product rule. Brittany, you can try that one as well. Y dash. Okay, so we differentiated once, differentiated twice, plug into the original differential equation, and we try to obtain the value which turn out to be 0, and therefore y2 is equal to x e power x is also a solution of given differential equation. So we got two solutions of given differential equation. There could be more than. Now the question says they should be linearly independent. So obviously your y1 over y2 or y2 over y1 doesn't matter. E raised to x over x e raised to x, which is 1 on x, which is not a constant. And therefore, what you got is e raised to x and x e raised to x are two linearly independent. You can write in full if you want. Solutions of given differential equation. Right? So we verified that part, which wasn't that bad. Now, what we should do, the question says, find out YH. How do we find out YH? YH is C1Y1 plus C2Y2, right? C1 e raised to x, C2x e raised to x. That is the solution. In doubt? No, okay, cool. That's good. We could have verified it theoretically, that they are linearly independent, but that's not really essential, right? As long as they are not multiple of one another, they are linearly independent, right? Okay. Cool, then let's keep going. Okay, so that one is on page 35. Verify yp is equal to x is a solution of this inhomogeneous equation, and then construct a general solution of this ODE. Okay. So first thing first, what you do? We plug it in the left-hand side and verify it equals to the right-hand side. Okay. So YP is again a symbol that technically means Y. YP, YH, YG, they are all symbol Y1, Y2, but they represent the value of the solution of the variable that is Y. Okay. So if you want, you can YP is equal to X. From that, Y dash is 1 and double dash is 0. Plug it in. Y double dash minus 2y dash plus y. 0 minus 2 times 1 plus x turned out to be x minus 2. And that is your RHS or right-hand side. Okay, and that turned out to be correct, and therefore YP is equal to x is a solution of particular solution, I should say, is a particular solution of inhomogeneous equation or the differential equation. Now, this is the same example we just now studied, right? How do you find out the general solution? Okay, for the YH part, for the homogeneous part. Y double dash minus 2y dash plus y is equal to 0, right? The solution is seen in example 1.18. The solution is yp is equal to y1, y2 is equal to x e raised to x. Okay. Right. Um, so I was just thinking about um, if that's your question, that what if example 1.18 is not given? What would you do then? Right? So very soon in today's session, I will introduce some technique of solving or getting this solution of e raised to x and x e raised to x. Right? For now, just adopt that they are the solution and we verify they are the solution in just a previous example. Right? Now, we were discussing one more thing, that why do we have to, please refer to this slice where it says the solution has two parts, YH and YP. H for the homogeneous part and YP is a particular solution for the non-homogeneous part. Okay, and example 1.18 was already homogeneous. We only talk about the YH part, right? That is already Y1 and Y2 is there. Okay. In this example 1.19, it's a non-homogeneous, inhomogeneous as well. So we start with YP, which is X, we verify is the solution. And then as we've seen here for the zero part, for the homogeneous part, EX and X e raised to X are the solution. Now we write it up. How do we write it up? We finally write everything and okay. Right. The solution, we call it Y O Y G YH plus YP, right? For the homogeneous part, we know C1 e raised to X, yeah? Because we know C1 Y1 plus C2 Y2 is a solution, right? C2X e raised to X. For the YP, we know X. Just keep e raised to X outside that. You can write C2X or XC2 up to you. This is the general solution, YG or Y. Again, please remember YH, YP, Y, YG, Y1, Y2, they are all symbols. They ultimately represent the value of the solution Y. Okay. Now we talk about second order constant coefficient homogeneous linear order. Constant coefficient. So your Px and Qx is A and B, some constant, right? If it is a constant, like various book has various approach, but what you will do is convert them into quadratic equation. Now treat this d square by dx square as a d, and then you talk about solving it. So there are a couple of cases that we will see. Where is it? Yes, a couple of cases that you will see here, which I'll explain everything step by step. There are three, some book talk about four cases or three or four cases, right? To follow here, right? And honestly, let me tell you one thing. I'm not sure how many of you in your grade 12 had rely on more than one book, right? But idealistically, there is nothing like a textbook. There are always reference book at uni level, right? So if you want that everything, you come to a lecture, listen to my recording or attend face to face, or via Zoom, and then you would know everything. That may not always work. It worked so far. It doesn't mean that's the correct approach. We are into university education, higher education in other terminology, where you need to refer more than one book. So go to library, wherever campus, whichever campus you are, wherever you are, and browse through some ODE, ordinary differential equation. And I'm sure we have more than one book available. Just browse through those things. So we are not sticked by one set of terminology or the symbols. You will open up a lot of possibility of understanding in your brain, right? At least pick up one or two other book apart from what we are following right now. There is a good book of Grazing. It's also called, calculus book. It's called technical maths book, engineering maths book, applied engineering math. So many various code. As long as it contains ODE, just pick up one book, start reading it, right? It will really, improve your understanding, the basic understanding, right? Okay. Right. So the general solution that we will have here, the YH part, because it's a zero part, right? YH part, C1, Y1, C2, Y2. But how do we find Y1 and Y2? Okay. So that we will take as e raised to x, right? You can go for 3 and 4 order as well, right? Let's try if y is equal to e raised to rx. Some books call it mx, will work as a solution, right? What will be your y dash is r e raised to rx. Y double dash will be r squared e raised to rx. Okay, once you plug that in the equation, what will you get? R squared e raised to rx, ar e raised to rx, and b e raised to rx is 0. Let's take rx outside. R squared plus ar plus b is 0. Now, e raised to rx can never be 0 for any finite value. That will leave you to r squared plus ar plus b is equal to 0. Now, over here, it looks like a and b are unknown, but they are constant. They will be provided in the question. So that's a quadratic equation. How do you solve a quadratic equation? How do we solve it? Normally, we have quadratic equation. I'll write in capital so we don't get confused. X is equal to minus b plus or minus b squared minus 4ac over 2a. Yeah? So x will have two roots there. Okay? Up here, my capital A is 1, my capital B is A, and C is B. Yeah? Okay. So minus A plus or minus A squared minus 4b over 2 times 1. Yeah? Don't worry about if you're getting mixed up because A and B again are symbols, right? It will be provided to you. So this is how you find out two solutions, right? If you call them R1 as minus A plus or minus A squared minus, sorry. Yeah, I'll just call it okay, I wanted to separate that. And your R2 will be minus A squared minus 4b over 2. Right? And therefore, your solution, you will get it very easily, right? The solution, once you get the value of R, Y, solution C1, Y1, C2, Y2, you plug that back in, the value of R1 and R2. Yeah? So that will be C1 e raised to R1x plus C2 e raised to R2x. Now, the thing here, we always wanted to make sure that they are linearly independent. So if the roots are repeated or roots are complex, we will change the approach a bit. Okay? So let's dive deeper into it and verify a couple of cases. Yeah. So far, so good?
Give me 2 seconds, just writing.
Sure. Yeah, sure. Right. So we were discussing about how come this has derived. Okay. So when we started, we are talking about two solutions. But up here, we only started with, okay, let me change the color. Y is equal to e raised to rx. So when I got my two r values, I'll plug that in because ultimately I need y1 and y2. Like I said, y1, y2, yh, yp, yj, they are all symbols. We are only talking about solution of y. And in order to avoid the confusion, we introduce, oh, this is for homogeneous, this is for particular, this is for general, this is y1, y2 as a two different solution, right? So y will have two solution, which is y1 and y2. The only difference it will make is based on r value, right? Otherwise, it's e raised to rx. If R is the same, then it's only one solution, which is not good. We need two linearly independent solutions. So Y1 will correspond to R1, Y2 will correspond to R2. Okay, I got two different values, right? So can I safely say this is e raised to R1x and this is e raised to R2x? Does it make sense? Rather than Rx, because I got two different values, I will call it R1 and R2 to make it looks like Y1 and Y2. Yeah. So again, my solution YH for the homogeneous equation C1Y1, C2Y2, right, will be C1 e raised to R1x, C2 e raised to R2x. Make sense?
Yeah.
Yeah. Because my in general solution was e raised to Rx. Yeah. So Y1, R1, Y2, R2. Again, there are two different solutions.
Yeah.
If the symbol makes you confused, don't worry. Once we look at the example, it will, there's nothing. I was unnecessarily making it difficult. Yeah.
Yeah.
It's very simple. Okay. Right. So like I said, based on the quadratic equation, because a quadratic equation can have three types of root, remember? Where the roots are distinct, not repeated. The roots are repeated, like a perfect square quadratic equation, like x square minus 2x plus 1 situation, yeah, where the root is x is equal to 1 and x is equal to 1, repeated. And the third one, your discriminant is less than 0. This thing here is less than 0. So as a kid, as a lower grades in our high school or even lower high school grades, which is no solution. As we grew up, we introduce complex number and it's, the solution exists, but it's not real. We call it complex numbers, right? So again, three solution. Discriminant or delta or d greater than 0, two distinct root, d is equal to 0, two roots but repeated, and d less than 0, complex root, non-real roots. But again, they can be separate or repeated, right? And that's why if they are separate, that's fine. If they're repeated, we go for the fourth cases, which is not covered here, but I will still tell you in case you come across anything where you need the fourth case. And that's why I keep on saying, don't rely on one book. No book is ever perfect. Even if I write a book, I will not ever claim this is the Bible, this cover everything. No, it's not possible. Others that can be read. I have one book here. I'm not sure if you can see that on the screen, but it's that thick.
Yeah.
Right? Yeah, and that is about 1,500 plus pages. Yeah, maybe this book is not perfect, but nearly perfect because it is that big. Yeah, we'll cover most of the section and in depth, right? Okay, cool. Let's keep going then. Let's look at the first case. Two distinctive real roots, R1 and R2. So your root term, again, don't worry about the symbol. This A and B is just a symbol, right? If you still wanted to remember, this is your A minus 3, and this is your B, right? Always remember what is given to you, right? Y double dash plus AY dash plus BY, if you want to write it. Y double dash plus AY dash plus BY is 0. Okay, right. Okay, I'll change the pen color to green. So what we do? My A is -3 and B is 2. Obviously, in the exam or in the assignment, it will not tell you which case it is. So there are three cases. Like I said, I'll quickly revise, preview them. So that's the first case. That's the second case where your discriminant is 0, right? Again, an example of that. And that is the third case, right? Where it is less than 0, right? So obviously, the question will only say this, find the solution, right? Find the solution and given condition. So get rid of C1, C2 as well. Okay. Again, the question will say find the solution. Right. FYI, this question is on page 36 of the prescribed book. Right. So what we do, we got A and B. Now we form the equation. What was the equation? R square minus 3R plus 2 is 0. What I did, rather than y double dash, I wrote r square. Rather than y dash, I wrote r and get rid of y. You know how that works? Can I write? Okay. Let me write this bit differently. Okay. I'm just keeping y separate. And then d square by dx square, 3d by dx plus 2 of y is 0. Right? So d2y by dx2, keeping y separate because you are differentiating y twice. You are differentiating one and the y as it is. Now, if I represent with some symbol d here, what will tell this like? D square, where d is equal to d by dx. Yeah. Minus 3d plus 2. You call it d, you call it r, same thing. Yeah, so you got that. So what you do, get rid of this. If it is second order, you took r square, then r, and then constant term, right? You might encounter going further, fourth, fifth, third order, high order differential equation. That's fine. Technique remains the same. Yeah, technique doesn't change. Right. So you know the roots. This is very simple. I read some of the high school book and it says product sum factor, right? Or AC method. That's what I call it. It's 1 and 2. We know how to factorize this in third year of maths education, right? Okay, so we got this 1 and 2. The solution YH will be C1 e raised to Rx, C2 e raised to R2X. That's it. YH. I just write it so it becomes more familiar. My R1 and R2, R1 is 1, R2 is 2, right? Because once I got this, I is equal to 1, R is equal to 2. Yeah, I got two roots. Okay, therefore, my YH is C1 e raised to 1x or x or C2 e raised to 2x. Whenever we do that, we'll always, you don't have to, but we'll always verify that's non-constant, yeah? So you not end up getting linearly dependent, okay? And that's the solution, right? You don't have to, but how about we verify it? How about we verify whether this is a solution or not? Okay, so I'll do the verification part here. My YH is C1 e raised to x, C2 e raised to 2x, Y dash C1 e raised to x, 2C2 e raised to 2x, Y double dash C1 e raised to x, 4C2 e raised to 2x. The question I had was Y double dash minus 3y dash plus 2y is 0. So C1, I'm just verifying. Yeah, additional steps. Don't worry about doing it. Okay. I combined e raised to x part. Yeah. So there are three of them. E raised to x here, e raised to x here, and what did I miss? I missed e raised to x there. And e raised to x here. So what it will look like? C1 e raised to x, 3C1 e raised to x, plus 2C1 e raised to x, right? That's my first bracket. Plus the C2 part. 1, 2, and 3. Okay. 4C2 e raised to 2x minus 6c2 e raised to 2x plus 2c2 e raised to 2x. Actually, I'm verifying, so I shouldn't write e raised to is equal to 0 because I am verifying it, isn't it? Yeah. So I would write is equal to here, right? 1 minus 3 plus 2. So that's a 0 e raised to x. 4 minus 6 plus 2 plus 0 e raised to 2x, and that is 0. That's it, verified. So if we had any sort of doubt whether this is a solution or not, we verified it. Okay. Do it with all angles. Do it with every sort of angle that you can see, because this will clear your understanding, right? Now, further, in addition, if the question had given some initial value condition, right? IVP, initial value problem, right? Initial value given, like I think there was an example here, something like this. Yeah, then you plug it in your solution here, right? And then you will get value of C1 and C2. So that's your particular solution. YH, particular values are given. Okay, right. Cool. Not the particular solution YP, getting rid of C1 and C2. That's what I mean. Yeah, assigning values to C1 and C2. Right. I'm going to pause recording here, giving Brittany some time to practice this question. And those watching online, please pause it here. Give yourself a bit of time to practice this. Okay, so the first step here is to pick up the equation. Now, if you're struggling to pick up the equation, do as I did here, the D form. Where is it? The D form here, right? So you will never get confused. Okay, so I'll do that bit here. Can I write 3 yeah, just a dy by dx form. Now 3d squared by dx squared, 2d by dx minus 1, y is 0. There you got the equation, 3d squared minus 2d minus 1 is 0. Yeah. We follow the same notation, so we will say 3r squared minus 2r minus 1 is 0. That's your equation. Getting equation correct is a first essential step. Now from here, if you have forgotten how to factorize a quadratic, then it's time to refresh it. I mean, you can always go for minus b plus or minus square b square minus 4ac over 2a, the quadratic formula approach, or how would you factorize 3x squared minus 2x minus 1? I used to call it AC method. Sorry, it's the wrong word. I am calling it SC method. I call it SC method. What you do, multiply A and C, that's your first step. Yeah, A times C, which is negative. If it is negative, you subtract factor. What are factors of 3? It's 3 and 1. Yeah, if anyone has forgotten or needs some help here, please let me know. I got a very good slide developed for Math 11246, which I am also teaching this and term, and I also do previous term. There are many examples with step-by-step thing, because the aim is to save time. The more time you can save, I'm sure when you're writing the paper or the assignment there, you're prone to make some mistake, but if you have spare minutes, right, you can go back and check it or fix something, right? Had you known that it could be wrong, right? So how would you factorize 3, right? It's 3 minus 1, okay? So what will we write? 3x squared minus 3x plus x minus 1. So what I have done? Nothing literally. I just re-return my negative 2 as negative 3 plus 1. Having done that, we factorize in pairs, right? So that is 3x, x minus 1 plus 1, x minus 1. So 3x plus 1 and x minus 1 are my factors, right? I will do that step here. I'm not going for that quadratic formula. I'm factorizing it. Okay, and that gives me my R as 1/3 or R as 1. The solution we have is C1y1 C2y2 or C1 e raised to R1x C2 e raised to R2x. Doesn't matter if you got your R1 as 1/3 or R2 as 1/3, doesn't matter, right? Again, C1, C2, R1, R2 are just symbols, right? So C1 e raised to 1/3. I definitely mixed up something, didn't I? One of them is plus. Which one is plus? This is plus, so this is minus. Yeah, minus 1/3 x plus C2 e raised to x. That's it. That's the solution. Okay. Right. Let's take a quick 5 minutes break and we'll resume after the break. Okay, let's resume. So we got two more cases. Case 2, as I explained earlier, where we got repeated root, right? Just to refresh our quick memory, I represent delta as the discriminant. So the delta greater than 0, that's case 1. Delta is equal to 0, that's our case 2. And delta less than 0 is coming up. Well, delta represents the discriminant, how many roots exist of that quadratic equation. Right, so if R1 and R2 are same, okay, then you can no longer use the same Y. You need some multiple just to make it different. Otherwise, they are linearly dependent, and the linearly dependent solution doesn't work. Then you're talking about solution of a first order, not of a second order, as explained a bit earlier. Right, so everything remains the same. Only the change is your y1 and y2. Earlier it was y1 was e raised to r1x, y2 was e raised to r2x. Now is e raised to rx and x e raised to rx. Okay, and so your y edge will be changed accordingly. Okay, in this instance, we are given two values, so we can get rid of the c1, c2 as well at the end. Right. Let's begin. So we start by forming the equation. I'm not gonna to do the d form every time, but if you want, you can always develop that. R squared plus 2r plus 1 is 0. That means r is equal to minus 1 repeated root. Okay, r1 and r2 is a repeated root. Okay, right. So my YH, as I have here, okay. So the YH part is C1 e raised to Rx plus C2x e raised to Rx. So the YH will be C1 e raised to, because your R is -1. Yeah, so C1 e raised to minus x plus C2x e raised to minus x. This would have stopped here if the additional condition were not given. But since they are given, we will have to, put it in the equation and then, clear our C1 and C2. Right. Now, if I rewrite this, my YH or Y will be C1 plus X C2 e raised to minus X. Okay. Now you call it The question was in T or, oops, it was T. I should write T, sorry, my bad. Okay, that's everything T, sorry. My bad. Okay. Right. Now I also want to talk about the dash. So YH dash. Multiplication rule. This one stays as it is. E raised to minus t differentiation e raised to minus t, and a minus comes in front. Differentiation of this, which is 0, tc2 says c2 and e raised to minus t. What we did differentiation product rule, right? So this stays as it is. Differentiation of e raised to t, so minus comes in place. Then e raised to minus t says it is c1 differentiation 0, tc2 is like 2x. Differentiation is 2, right? If you simplify it, what you'll get minus c1 minus tc2 plus c2 e raised to minus t yh dash. Okay, yh dash. Why do we need it? Why do we need it? Because we are given the value of this. Remember, this is your t and this is your y. This is your y dash. Okay. Now, I prefer to do it here. Sorry if it looks a bit clumsy, but I don't want to flip the page or flip the slide. And I mean, this is my message as well. Many of the students make mistake when they flip page or get confused or absorb more time, right? Okay, I will write it here. Y of 0 is 4 and y dash 0 is minus 2. Okay. Right, once you put it here, this is your value of y, that is 4. 4 is equal to c1 plus 0 c2 e raised to minus 0, right? Inside is the independent variables, that is normally x, in this instance is t, right? So 4 is equal to c1 e raised to 0 is that. So we got c1 as 4. Okay, now I plugged it here, another one I'll plug it here. So minus 2 is equal to minus c1 plus 0 plus c2 e raised to 0. So minus 2 is equal to c2 minus c1, minus 2 is equal to c1 minus 4, c2 is 4 minus 2, and c2 is 2. I got my c2 as 2. That's it. See, you can call it multiple equation if that helps you. Call it equation 1, 2, and 3. When you do that from 2, here you can say from 3. Yeah, so you're clearly indicating what you are doing, right? So I got 4 and 2, awesome. From 1, my YH, which was C1 e raised to T plus C2 T e raised to T, yeah, or minus T. I replace C1 as 4, so my YH is 4 e raised to minus T plus 2 t e raised to minus t. You can combine it 4 plus 2t e raised to minus t, or even further 2 plus t e raised to minus t. Okay, that's your final answer. Whenever the additional values are given, you have to put them back. Okay, so let's keep going. Again, pause your recording here. Give yourself a couple of minutes to try this question. It's similar to what we have done. Give it a go. Right, so one of the easy question in case 2. So we write the quadratic equation 4r squared plus 4r plus 1. Please realize this is a perfect square, and this will be the case in repeated case 2. So r is minus half, which is the value of r. Once you got r, y at c1 e raised to rx, c2 x c2 e raised to rx, just replace the value of ice and give. If you want to keep e power outside, e minus half x outside, c1 plus x c2. You could have written where c1 and c2 are arbitrary constant, which you will find in some of the books here. Right. Third case, two complex root R1 and R2. Like I said, many book has the fourth case where they are repeated roots. Like this is only second order, so you won't have repeated, but what if it is a fourth order? Right? Then you might have four roots and the complex root could be repeated. Okay. But over here, we only deal with the three cases, right? Where the discriminant. So this is the third part here. I'll go back this part. Now we are talking about delta less than 0, right? That's the part we are at. Right. So the solution is y1 e raised to alpha x cos beta x, y2 e raised to alpha x sin beta x. And therefore the yh is you keep the e power outside, c1 cos beta x, c2 sin beta x. Now many of you will be wondering, why did we introduce cos and sin? Where did it come from? I'm not going to prove it. I'm not sure if you have proved it in a previous year. I'm not sure of the old content that you covered, not bit by bit. But what will happen when you talk about e raised to rx, that is e raised to alpha. I'll just stick to the plus part for now, plus I beta, that is e power alpha, e power I beta. Now, e power I theta or I beta is cos plus I sine, right? So that will be e cos beta plus I sine beta. That's a Taylor's formula and Maclaurin series and a lot of the expansion. I'm sure you have covered it, but I'm not going to touch that now. So this is how it looks like, e raised to alpha cos plus I sine. This is where cos and sine is introduced because e raised to I theta is cos theta plus I sine theta. Okay, right. So yh is e raised to alpha x, c1 cos beta x, c2 sin beta x. Follow the formula. You will surely realize that that's a complex root. Once you find out that, just plug in your alpha and beta in this solution and you'll be through. Right. So let's form an equation here. Again, those watching the recording can stop here. I'm going to continue. Oh, yeah. You want to try? Okay. Now, r squared minus 4r plus 13 is 0. That's a quadratic equation. We go for r is equal to minus b, the quadratic formula, plus or minus b squared minus 4ac over 2. And that would be simplified to r is equal to minus b. That would be plus. See, that's what I mean. We'll flip it. Not sure about you, but I'm in trouble. 16 plus 52. Did I do anything wrong? No. 16 minus 52. And therefore, 16 minus 52 is minus 36 over 2. Recall MATH13218, linear algebra, vector, and complex. Minus 1 is I square. So 4 plus or minus I square, 36 over 2. That will be simplified to 4 plus or minus I6 over 2, or 2 plus or minus I3. That's my R. Once you compare it with alpha plus or minus I beta, your alpha is 2 and beta is 3. The solution e raised to alpha x c1 cos beta x plus c2 sine beta x e raised to 2x c1 cos 3x c2 sine 3x. That is the value of YH, the solution. Right? Cool. Try one more. Y double dash minus 2y dash plus 25y is 0. Okay, so first step is to form the equation, which is r squared minus 2r plus 25 is 0. You could always go on with the, the quadratic formula minus b plus or minus root b square minus 4su over 2a and do it. But how about if I give you a new approach, right? So see, I always want your brain to think a lot, right? A lot differently. So that will be r squared minus 2r plus 1 plus 24 is 0. What am I doing? I'm trying to make a perfect square polynomial, right? So r minus 1 square is equal to minus 24, which is the same as 24i squared. Okay, and therefore r minus 1 is plus or minus I square root 24. So r 1 plus or minus I square root 24 is 2 root 6. That is your r, which you can always compare with alpha plus or minus I beta. Therefore, your alpha is 1 and beta is 2 root 6. Had you gone with the minus b plus or minus b square minus 4ac approach, you should end up getting the same thing. You will have square root 96. You should realize 96 is 16 times 6, and that's 4 root 6 and simplify. Right, so once I got my alpha and beta, I can simply have my y is e raised to alpha x. If you want, I can write here e raised to alpha x, c1 cos beta x, c2 sine beta x. So e raised to x, c1 cos 2 root 6x plus c2 sine 2 root 6x. If you want, you can write root 6x like this here. So you know that's your theta part. And that's the solution, right? Okay, so everything is presented in a summary here. So characteristic equation, which is r square plus ar plus b, if that's positive, two distinct rule, c1 e raised to r1x e to r2x, same root r1 r2, c1 e raised to rx c2 x e raised to rx, and less than 0, complex root alpha plus or minus r I beta, and yh will be e raised to alpha x, c1 cos beta x plus c2 sine beta x. Right, we got only few things to cover, only a few slides. Right, the same structure of solution to the second order constant coefficient homogeneous linear can be extended to any nth order constant coefficient homogeneous linear differential equation, right? So far we talked about second order. So you will get a quadratic equation. What if it's a third order? You'll get a cubic equation or biquadratic or 4-power equation or 5-power equation. Doesn't matter. You solve it to your best ability and then the root follow a similar pattern, right? If it's repeated, you go with the x. If it is 3, then, x square and you keep extending that, okay? Let's look at an example here. Right. So y5, that is a fifth order differential equation, 2y4, y dash and 2y. Let's form the equation from here. Okay, so we will say r5 plus 2r4 minus r minus 2. If you struggle, call it D, and D form will help you. D phi, I assume X, D phi plus 2 D4 phi by dx4 minus dy by dx minus 2y is 0, and therefore d phi dx phi 2 d4 by dx4 d by dx minus 2 of y is 0, and that's your equation. Yeah, if you want, write one more step. D phi plus 2d4 minus d minus 2, and that's your characteristic equation, right? Cool. We make pairs. R4 common, R plus 2 minus 1, R plus 2 is 0. So R plus 2 and R4 minus 1. Keep going. Don't rush to simplify it. A square minus B square approach. R square minus 1, R square plus 1 is 0. R plus 2, R minus 1, R plus 1, and I'll leave it R square plus 1 as it is. So the roots are minus 2, 1, minus 1, and from here, R square is minus 1, so R is equal to plus or minus I. If you want, you can write 0 plus or minus I 1. Yeah. So I got 5 roots. So I will talk about C1 to C5. Yeah. Over here is a case 1. This is case 3. Okay. Right. How do we write it? So the solution, if you talk about y1, will be e raised to r1x. So that's 1. y2 e raised to r2x. What was this other one? Minus x. y3 e raised to r3x, e raised to minus 2x. Yeah. For y4, I go with e raised to alpha x cos beta x. So e raised to 0x cos x. So simply cos x, that's my y4. And y5 e raised to alpha x sine beta x. Plugging in the value, I'll get sine x y5. Now the final job is to combine everything with constant c1 to c5. So my y is c1 y1, c2 y2, c3 y3, c4 y4, and c5 y5. c1 e raised to x, c2 e raised to minus x, c3 minus 2x, c4 e raised to, sorry, there is no e, c4 cos x, and c5 sin x. That's my YH, homogeneous. Right. We can extend this a lot, but for now, we are only sticking to second order linear ODE, so we are not extending it a lot, but you can by all means. Any questions? No? Okay, in that case, I thanks everyone watching the recording, and I'll see you hopefully today afternoon at 3 or this Friday, time TBA. And if not, I'll see you next. Oh, next week is a midterm break. Don't forget that. No scheduled class. I have deleted the link as well. So I'll see you in the week 6, 2 weeks time. Thank you.